Hello, class. Today we're going to start Chapter 7, and Chapter 7 has to do with the Pythagorean Theorem, the Pythagorean Theorem. So, starting out today, we're just going to try to understand it and also see a few cases where we can use it here. So, let's start us off with some definitions. We got three for us right now. So, our first is the hypotenuse. So, the hypotenuse is the longest leg on a right triangle. It will always be across from the right angle. In the Pythagorean theorem, it is labeled with the variable c. Now, next is the legs. So, the legs on a right triangle are the non-hypotenuse sides. They will always be to the right of the triangle, and they are labeled with the letters A or B. And lastly, the most important part of this definition here is the Pythagorean theorem. So, this is the way to find the side lengths of a right triangle. It reads a squared plus b squared is equal to c squared. So just to go along with that here, we have a picture that I wanted you guys to get down as well. So this is just a common right triangle here, right? And we call it a right triangle because it just has this right angle here like this. And a right angle is, of course, 90 degrees. So this is just a 90-degree triangle. So if we see here, we have our two legs, right? They're denoted A and B. Notice how they're to the left and the right of the right angle respectively, right? And if we go across from our right angle like this, we have our hypotenuse, and that is C. Now, the longest side on a right triangle is always going to be the hypotenuse. So it's always going to be across from the right angle here. This is the longest side. And we could use this formula, a squared plus b squared is equal to c squared, to find any of the lengths of this triangle here. So our goal today we are going to begin working with the Pythagorean theorem. We will use the Pythagorean theorem to find the third length of a triangle given the other two. So maybe we're given A and B and we need to find C. Maybe we're given B and C and we need to find A. But basically we're going to have one missing piece and two known pieces, and we're going to have to solve for it. All right, so on this one, we want to find the length of the hypotenuse. So first, as always, just like when we were doing volume formulas, we want to start off by writing down our formula here. A squared plus b squared is equal to c squared. All right, so let's call A is equal to 6 and B is equal to 8. Really, the order of these doesn't matter. This could be B and this could be A, but however you guys want to do it, one has to be A and one has to be B. The important one is that the hypotenuse is always C. All righty here, so A squared, so we have 6 squared plus B squared, which is 8 squared, is equal to C squared. So remember, a squared number means that number times itself, right? So this is 6 times 6 plus 8 times 8 is equal to c squared. All right, so 6 times 6 is 36. 8 times 8 is 64, and that's equal to c squared. 36 plus 64, that will give us 100, is equal to c squared. All right, but we don't want to know what c squared is, right? We want to know what c is, because c is our hypotenuse, not c squared. So what that means is we have to take the square root of both sides of our equation here, square root. So obviously a square root of a squared number will cancel. On the right side, we'll have just c. And on the left side, the square root of 100 is 10, because 10 times 10 equals 100. So that means my hypotenuse right here is 10. All right, so just that one formula for us, right? Not too bad, I hope, but we're going to try some more examples as well. Make sure you guys are getting down these examples in your notes. All right, next one here. Find the length of the unknown leg. All right, so obviously you have c equals 6, right? Let's say this is a equal to 5, and we want to solve for b. So as always, we're going to start off by just writing down our formula. A squared plus b squared is equal to c squared. And now from there, we're going to try to plug in some numbers. All right, so A is 5. We're going to plug in 5 squared. We don't know B, so it's just going to remain B squared. But this time, C is equal to 6. So C will be equal to 6 squared. All right, so B squared is 25, or excuse me, A squared, 5 squared, whatever I'm saying. 5 squared is 25, plus B squared will be equal to 6 squared is 36. All right, so this just becomes an algebra problem for us, right? What's the opposite of adding 25? Well, that means we have to subtract 25 from both sides. So 25 minus 25 is obviously 0. So on the left side, this will be just b squared. And on the right side, 36 minus 25 is 11. Alrighty, now we got to take the square root of both sides because we don't want to know what b squared is. We want to know what b is. So square root of b squared and square root of 11. Square root of b squared will obviously just be b. And the square root of 11, since 11 doesn't have any numbers we can factor out or anything like that, we can just call this here the square root of 11. Alrighty, so hopefully we're getting the hang of this here. It should be pretty similar to our last one where we're just plugging in numbers. Okay. All right, find the length of the hypotenuse when x is equal to 12. All right, so it looks like we just got to plug our numbers in here, right? So 7 times, we'll call this A, right? We'll say that's A and this is B. So 7 times 12 plus 6. 7 times 12 would be what? Is that 72? No, that's wrong. That's 84, sorry. 84 plus 6 is equal to 90. So side length A over here is equal to 90. For side length B, we have 5 times 12. 5 times 12 is equal to 60. So B right here is equal to 60. All right, now let's go plug these numbers in here. We're going to have some quite large numbers, so hold tight with me here, folks. All righty, so a squared, or let's just start by writing our formula. A squared plus b squared is equal to c squared. A is 90, so we have 90 squared. B is 60, so plus 60 squared. And that'll be equal to c squared. All right, so 90 squared. 90 squared is going to give us 8,100. 60 squared is going to give us 3,600. And c squared will remain c squared. Now, 8,100 plus 3,600 is going to give us 1,700. And that'll still be equal to c squared. So now we got to take the square root of both sides here. The square root of c squared is obviously just going to be c. And then the square root of 1,700 is going to be approximately 108.2. Which means this side length right here would be 108.2. All right, you could also just leave it as the square root of 11,700 for now. But if you want to approximate it, we could say it's approximately 108.2. All right, so let's go check through some practice problems here. So I want you guys to find C when A is equal to 2 and B is equal to 3. I want you to find C when A is equal to 8 and B is equal to 15. And I want you to find B when C is equal to 8.7 and A is equal to 6.2. I'm going to go ahead and try those out on your own. If you have any questions on those, ask me in class tomorrow and we can go over them. Alrighty, so don't forget to write your conclusions, guys. It needs to be 2 complete sentences, not just what I have written here. When I check your guys' notes tomorrow, if we don't have 2 complete sentences, you will not be getting a stamp. So in conclusion, today we learned to understand the Pythagorean theorem, and we used it to find the missing side lengths. Alrighty, guys, I hope this helped you out here. You guys have a great rest of your day, and I will see you all tomorrow. Bye-bye, everyone.